Yeah, so we have projects out there, typical house, 3,500 square foot, running cost £1 a day on average, so about £360 for the full year. That would be running cost for heating, cooling as well in the summer, and hot water. So if you took the cooling of about 30% out of that, you're probably realistically for heating and hot water about 250 quid for the year. Um, how that house achieved £1 a day run cost, we have an integrated system where the heat pump and the solar are working completely in tandem. So, for example, if your solar kicks in at 10 o'clock in the morning and starts producing 3 kilowatt, it triggers our heat pump to come on, starts using that electricity to bump up the hot water temperature to a higher temperature, and will also increase the underfloor heating up 1 or 2 degrees. What that means is that if your house is so well insulated and airtight, you've generated enough heat via your solar and your PV and your heat pump to heat that building throughout the day when you've got free electricity. The thermal fabric will mean that temperature will be sufficiently kept overnight that the system doesn't have to kick in again until 9 o'clock the next morning. It just goes on repeat. So that's how that has been achieved. So that particular house, like, we're starting to get into the colder weather now in October. For the last week, the heating hasn't even been on because the fabric, the insulation and airtightness is done to such a good spec that the low energy home means that the renewables complement it really, really well. So going to come back to some other things in that one, we worked closely with the architect in getting the plant room that was central. So that meant that our hot water tank and heat pump, everything was close together. We didn't have long pipe runs. The other thing was the wet rooms, like the bathroom en suites, are all within about 4 or 5 meters of the plant room. So you don't have big, long hot water runs. You don't need a recirculation pump running to pump water in your house. It's all them small things that all add up. Another crucial one was the heat recovery ventilation system is all within the thermal envelope. So all the plant, the manifolds and the ducting is all within the insulation and airtightness layer. What that means is that you don't have a unit that's sitting in a cold attic space, so that when you recover heat from your house, it loses 20, 25, 30% by going into a cold attic and then going back into the house. So all them small things add up, and that's how this house has achieved £1 a day running cost, because it's a factor of about 15 or 20 things. It's things that we've picked up over 15, 20 years of experience and knowledge gathering that we are now offering this sort of advice to complement our systems to our self-builders and architects. So it means then that anybody looking to achieve this running cost, it's totally achievable. So it is. It's just by doing all the small things and doing them properly. Looking at a capital cost of a boiler system over a heat pump, you're generally going to be maybe 3.5, 4 grand less by putting in a boiler at your initial build stage. Where you'll see savings straight away is your running cost, especially if you've got underfloor heating in your house, because heat pump and underfloor are a great match. It just means you're getting your running cost down as low as possible, because you can run that system up between 20 and sort of 35 degrees. Running that really low temperature means your heat pump is really efficient and has lower running cost. The issue I've seen in houses with oil boilers over the years linked to underfloor is that it's very hard to control. Oil boilers obviously are running at 70 or 80 degrees. They have to come to a mixing valve, and the mixing valve has to cool that water down to 35, 40 degrees. And even for a modern house, that's too high a temperature. So what we found is people then tend to try and save money or get a better comfort level by turning the boiler on and off. And that's not the way to run underfloor heating. The underfloor is best run just ran steadily. The heat pump just injects a little bit of heat in throughout the day, and that can be done during the hours of solar production, even better. But the other thing to mention too, I suppose, is that you only have one utility bill, it's electricity. You don't have to worry about oil running out or getting gas topped up. You only have electricity. So come back to our term of fit and forget. Like, that's one of the things that our clients love about our systems, is that it's just there, and you get your monthly direct debit for your electricity, and you know what that sort of is month by month. So in terms of even budgeting for your family, you know that my electric bill is sort of in around 150, 200 a month. That's pretty good in terms of looking at book a holiday and stuff like that. And it's just the issue of when if the oil does run out, and it's 8 o'clock at night and it's freezing outside, going to try and bleed the boiler. We just don't have them issues. And we just find too, even the heat pumps we work with are really reliable now. Pretty much, there's a very odd issue, but it's few and far between. So like we're doing a project in the minute for a developer who's putting a heat pump into his own house. And I was down on site with him one day and he got a phone call about houses that he had where the oil boilers were all breaking down or there was issues with them, and he was sort of going a bit demented. So it just made me think, God, the systems we do are actually really good and really efficient and reliable. So my advice to people is do your installation well, get your air tightness measures done, look at thermal bridging, get the heat load right down, and then put in a system that is sized to heat your house. So our heat pumps typically will range from, say, if it's a 200 square meter house, that'll be a 1 to 6 kilowatt heat pump, which means that it can operate down as low as 1 kilowatt or up as high as 6 kilowatt. Typically, most boilers are in around 15, 20 kilowatts fixed output. So there's a case where already the system is oversized for that property, and that means it's just not performing sufficiently. Yeah, so if you're building a new house and you want to know what your estimation of running cost is going to be, we can do that for you and compare that to gas or oil. So I done one there actually this morning, and the payback, if I take the current oil price was 52p a litre, which is quite low at the moment. Normally hovers in around 60, 70, 80p, and it can peak at 90p or a pound. But that example this morning was 52p, and I compared the current electricity price, taking into account that you might go with a economy 7 type tariff, which a lot of people do now, and then you also got maybe a solar system producing a lot of free electric during the day. But the standalone cost of the heat pump versus the oil boiler, your higher capital cost of about £4,000 or £5,000. Typically the running cost there, we've worked out for that particular project this morning, the annual running cost with the heat pump with the solar linked to it was about £500, £600 a year, and then the equivalent cost with oil is about £1,200, £1,300 a year. So roughly it was a payback of about 10 years. But then if I change that oil price to 65p a litre, which is probably more normal, the payback reduces down to about, the payback period reduces down to about 7 years. So it does. So typical lifespan of the different technologies, overall, you should be looking at anywhere between 20 and 30 years. I've been to Switzerland and different countries that have heat pumps. I was over there in the mid-2000s. I went to visit a guy's house. His heat pump was in 28 years and performing still efficiently. So that's what you can expect. I do expect ground source should last longer than air source because it's obviously built, it's in the house. It's not exposed to elements. So, in theory, it should last longer. But your mechanical ventilation, your solar system, typical panel lifetime is 25, 30 years. We do offer a preventative maintenance contract that's just come out every year, just checking about 30 or 40 things over the range of the different technologies that we work with and make sure that everything's in order so you don't have unexpected breakdowns in the middle of the winter. So if you're going to contact us about your upcoming project, we do say to people, get in touch early and get in contact at the very early stages of your project when you're in the design stage, because we can have better control and influence over what happens at the early stage of your project. The best contact number to get us on is 028 9266 7745. And if you want to email us your project details, email info@Daly, Daly Renewables.com. So if you're contacting us about your project in the Republic of Ireland, our contact details, our phone number is 047 67 227.